Okay, so let's start with a wild thought. What if your computer could actually get sick? I don't mean just running slow. I mean, what if it could catch something contagious? Well, that's exactly the lens we're going to use today as we dive into the wild world of computer viruses.
It sounds a little weird, right? But that one question is pretty much the key to understanding all of this. Because in so many ways, a computer virus acts just like a biological one. It finds a host, it makes copies of itself, and then it spreads. So, for this explainer, we're basically putting on our digital lab coats. We're going to start with a diagnosis to figure out what this thing even is. Then we'll dig into its origin story to see how it's made. We'll track the outbreak, spot the symptoms of an infection, and finally, we'll look for the cure in our digital immune system. All right, first things first, the diagnosis, because you can't really fight an enemy until you know exactly what you're dealing with. So at its heart, a computer virus is really just a piece of code that has two main goals. Number one, mess with how your computer works without you knowing. And number two, make copies of itself so it can jump to other machines. It's basically a digital parasite. And this is where the comparison gets really, really cool. Think about it. A biological virus, like the flu, needs a living host cell to replicate. Well, a digital virus needs a host program, like an app or even a Word document. A cold spreads from person to person. A computer virus spreads from computer to computer. And while a real virus carries genetic code, a digital one carries malicious code, which we call its payload. That's the part that actually does all the damage. The parallels are kind of uncanny. So where in the world do these digital germs even come from? Well, to figure that out, we've got to look at the anatomy of the code itself. Making a simple virus isn't some dark magic. It really just boils down to 3 steps. First, the coder writes the part that lets it spread, the propagation code. Second, they build that payload we talked about, the bit that's going to cause trouble. And third, they attach the whole thing to a totally normal program, hiding it where an unsuspecting person, maybe you, might click on it. And why do they do this? It could be for money, for politics, for spying, or sometimes just to watch the world burn. So yeah, here's the key takeaway. No matter how fancy or complex a virus might look, it always comes down to these 2 simple goals. Replicate so it can survive, and deliver its payload to complete its mission. It's a simple formula, but man, is it effective. Okay, so we know what a virus is, and we've got an idea of how it's built. But how does it actually start an outbreak? I mean, how does one single infected file on one computer somewhere in the world lead to a massive global digital problem? The answer is us. In the digital world, we're the ones who carry it from place to place. And these right here, these are the digital versions of a cough or a handshake. The classic one, of course, is the sneaky email attachment, but it could just as easily be a sketchy software download, a bogus link on a website, an old USB drive you found, or even a weakness in a network that lets the virus spread all by itself. So, let's say it happened. The infection is successful. The virus has a new home. What's next? Well, now we start seeing the symptoms. And let's be clear, the impact here isn't just a technical glitch. We're talking about real-world, personal, and financial damage. A virus can be anything from a tiny annoyance to a complete catastrophe for a person or even a huge company. These symptoms can show up in all sorts of ways. Sometimes they're super obvious, like your files suddenly getting deleted or your computer crashing all the time. But sometimes they're subtle. Maybe your machine is just a bit slower than usual. Because behind the scenes, it's being used in a botnet. That's a whole army of infected computers to attack websites without you ever knowing. And the scariest part? Sometimes the virus is totally invisible while it quietly steals your passwords and bank info. Okay, I know, that all sounds pretty bleak, but it is not a lost cause. Just like our bodies have an immune system, our digital lives have defenses too. This is the cure. Our digital immune system has a few different layers. Antivirus software, that's like your white blood cells, actively hunting down known threats. Firewalls are like your skin. They create a barrier to stop things from getting in. And software updates. Think of those as vaccines, patching up weaknesses before a virus can get to them. But the single most important defense, the one that makes everything else work, it's your own caution. It's your brain. Just being smart about what you click is the best defense there is. Period. So I'll just leave you with this question to chew on. As we all get more and more connected, is some kind of massive digital pandemic inevitable? Or can our collective immune system, our tech and our own common sense, evolve fast enough to stop it? It's definitely something